All right, everybody, and we are back. The last time we met, we were working on a problem. We didn't finish it, so I want to finish it today. What is this? What is this? What is this? This looks kind of interesting. Is this a problem day thing? Oh wow! Oh my God, Decode, you impress me every day. You know what? We should do this problem day thing some other time. We should do a problem day thing. I've been told that I don't stream enough, so I'm trying to change that. Alright, we're back. Alright, minimum number of arrows to burst the balloon. Alright, just to refresh everybody's memories, balloons are given to us as a list of start and end intervals. So it's a list of intervals. We don't know where the balloons are in terms of their y-axis, and in a way we don't care as long as we fire an arrow within that interval along the x-axis. We know we're gonna hit it no matter where they are on the y-axis, so that's why we don't care. So the problem here is, given a list of balloons, which is a list of intervals. For instance, this would be 1, 2, 3, 4, 5 balloons. We want to find out the minimum number of arrows we need to pop all the balloons, which means we need a set of numbers of indexes such that all intervals contain at least one number from the set, and this is the smallest set possible. Okay, so last time where we left off, we had a solution which I'm convinced works. I'm very sure this solution works. The only thing that's the problem that is the problem with this solution. So again, a quick recap. What the solution does is, first we sort the balloons according to their start index. So here are 4 balloons sorted by their start index. These balloons are also sorted by their start index, and then we just go along the x-axis, right? We have an arrow and we just keep going, and then we find the first place where we're not able to go anymore without firing. So that's defined as the right hand side of a particular interval. For instance, here, if there are no arrows here, if this balloon number 3 still remains unpopped, if balloon 3 is not popped, then moving this arrow A past this index would mean that balloon 3 is never going to pop. So we need to find an arrow here, right? If there are no arrows before this that pops balloon 3, we need to find an arrow here at the very latest in order to pop balloon 3. And after we do that, we'll mark all the balloons up to 3 as popped. Sorry, not just all the balloons up to 3, but all the balloons whose left hand side is smaller than this index over here. We'll mark them as popped. So that's this line over here in our pseudocode. Pop balloons up to any balloon whose start is smaller than b dot n. Okay, so this solution works, except for a red tricky problem. Okay, we ran to this problem where there's a test case that failed, where we have this giant massive balloon. Let me see if I can find the test case again. So that's basically the issue with this particular solution, is that there's a giant massive balloon. Yes, there's one giant massive balloon that goes from index 1 all the way to 2 trillion something, right? This is a massive balloon, and because our algorithm moves the arrow one space at a time to keep going, it takes a very long time for us to get all the way to the end, and so our algorithm times out. So what we want is something that is a lot quicker. We want something that scales only with the number of balloons and not how wide the balloons are. Okay? So to do that, instead of saying A in range n max plus 1, what we want to do is we want to find the next smallest integer. Is we want to do we want to iterate first. We want to iterate okay, and we want to find the smallest integer. We want to find the smallest integer, n's, which, like I said, n's are the ends of the balloons. So the right hand edges of the balloon. This is an n, this is an n, this one is an n, this one, and this one. We want to iterate over the ends, and we want to do it cleverly. Essentially, we want to find the next end that's unpopped and is the smallest. Find the smallest end, the unpopped balloons. Okay, we're going to find the smallest end among unpopped balloons. Because our balloons are sorted by their start, their left hand sides, we know that when, based on that, using our algorithm, if we pop balloon, x, all balloons from x, from 0 to x are all popped. So we only need one popped here to deal with that. Okay, so instead of doing A in range, what we want to do is we want to say A equals to smallest end that is not popped. And we can actually do that. I'm pretty sure there's a Pythonic smallest value in a list. Find smallest number in a list. Yeah. Find index of smallest value in lists. Let's see, what's the most Pythonic way to do this? Range 1 to, okay. Built-in function. Okay, this might be a little bit slower. So it says here min pos equals a dot index min a. This might be a bit slower because min a takes some time to traverse the entire list to find the smallest number, and then index does something on top of that, which is it will traverse the list again. So this is a little bit slower, but I like to use this. I would like to use this, and the reason is because in this toy program, as well as I think in most real-world scenarios, the problem that we have is not traversal of the list. Okay, the problem that we have is not traversal of the list. So the reason why our code failed on this example is that this number is extremely large. We are unlikely to get a list with this many elements. So even though it's a little bit slower, we're gonna try with that first. And if it's really, really slow, if it's unbearable, then we're just gonna do it again. Okay, so we're gonna do this. We need some kind of while loop here because we're gonna keep repeating ourselves. And we're gonna say A equals the smallest n that is not popped. And how we're gonna do this is we are gonna say hence we are going to take popped colon pop plus 1 colon actually. So we're not going to start at the beginning of nth, we're going to start everything that's popped. And we're going to say min of this. We're going to say give us actually the first index. This is really what we want. Which is really what we want. Not that it matters very much. Well, A, yeah. Okay. Well, popped is smaller than n's length of n's. A equals, and then I think this should do it. Pop plus 1. And then popped will, yeah. So pop will correct itself. Okay, so we don't have to do this. We don't have to find the matching unpopped. Actually, it's not A. It's balloon. We don't need this anymore. I'm pretty sure. Let's just run it. See what happens. Min arc is an empty sequence. Okay. Plus 1. How can this be? Well, let's bust out Python tutor. See where we're at. You know, the day will come when I finally give up on Python tutor and we use a real IDE to help us step 2. How cool. That day is not today. Let's visualize execution. Let's get this. Don't need this here. Let's visualize execution again. Okay, cool. So we're in business. It says here, something gone wrong. So balloons, it says that ends popped plus 1. So this is not equals. You see what's happening here? What's happening here is actually popped got to 3. So balloon 0, 1, 2, 3 are all popped. And now ends only has 4 elements. Its last element is 3. So that's why that doesn't work. This should be smaller and equals to ends. Let's try it again. We should also try it here in real time. In case the other one doesn't work. Visualize execution. Okay. Oh. Pop is smaller. Okay. Minus 1. Smaller equals len, we'll have the opposite effect. So in this case, len is 4 and 1 pop to be at most 2. If pop is 3, then we're done, right? If pop is 3, it means that all balloons are popped. Balloon number 3 is popped. Okay, we're going to run it. Okay. Wait, did it finish? No. Let's see what's happening here. Okay, so something happened. Alright, points, blah blah blah. Alright, cool. Now we're talking, now we're in business. Max ends, okay. So the first value of balloon. Okay, we have to go past this a little bit. This is not the balloon that we care about. Okay, so the first value of balloon is 0. That's correct, because balloon 0, well, at least in the sorted version, is 1 6. Okay, its right hand side is 6. So popped starts and stop on balloon. Everybody who's balloon, so pop should be equals so IDX is 0. Yes, so you should pop this balloon. Okay, and then now it should pop the other balloon. Pop equals 1. You should pop both balloon 0 and balloon 1. So balloon 0 is 1 6, balloon 2 is 2 8. And because we are firing at position number 7, oh sorry, for firing at position number 6, for firing at position number 6, A equals to 6, even though it's not listed here, we're aiming at balloon 0, and right hand side of balloon 0 is 6. It should hit both balloon 0 and balloon 1. So IDX is now 2. Start of balloon 2 is 7. It's over here. That's why IDX is 2. Start of IDX is 7. So it should not hit this balloon. Yep, it breaks. Okay. Why is it still doing this? It's because I'm doing this. Shots fired too, yep. So returns arrows fired. I think this should be correct. Let's submit it. I'm surprised it wasn't done running. Hey, accepted. Check this out. It took 9 seconds. I don't think this is particularly great. I think there's some optimization we could do around here. 9 seconds. Okay. So let's see. We could probably write our own custom function to do this. Let's see. Now, so this takes about 9.3 seconds, alright? So doing this takes about 9.3 seconds. I'm a little bit curious how long it would take if we wrote our own little function. Find next balloon. And this is not a very descriptive name. So we're going to write comment the next balloon to pop. This is the unpop is next balloon is the unpopped balloon with the smallest end. You need ends. You need popped. I think that's about it. Ends about so for I range pop basically ends length ends. Yeah, so from pop plus 1. So we don't have to do any boundary conditions because we assume -1. Yeah. So we write down assumptions here. Okay, this is going to be helpful to you when you come back and read your code later, because I promise you, you're gonna come back in a month and wonder what happened. You're gonna come back some other day and you say, oh hey, I get this handy function right here, and you try to use it, and something, all hell breaks loose, because when you came back, you forgot that this piece of code has a vital, critical assumption that you violate next time you use it. So for I in range pop plus 1 length, okay, actually smallest equals pop plus 1. Smallest equals ends, small idx. Okay, cool. Return the index of the next balloon pop. Okay, so again, write down your assumptions, write down what this function does. Commenting is very important. Obviously, it doesn't make a difference here since I'm dealing with a machine, and it's a very small program, but in real life, make sure you comment your functions with things that are useful. Okay, I see a lot of people write huge manifestos. This is a function, blah 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 blah. And everything they write is super obvious. They'll write things like, and they write pointless commands like this. I've seen this poor mess. Find the next item. This is the worst kind of comment. Alright? Never write comments like that. It's better to leave that function uncommented. Anybody who says, oh, you should always comment your functions, even if the function is completely, even the command is completely nonsensical, they don't know what they're talking about. Alright? Okay, for I in range, pop plus 1 ends. Okay? If smaller than smallest, small idx equals 2i, smallest equals ends I. Okay. Okay, cool. Let's run, see if this makes it a little bit faster. I doubt it, but who knows? Stranger things have happened. Okay, so time to beat is 9 seconds. Oh, runtime error. Find next balloon. To self. Find next balloon. Wait, I do have a. This makes no sense. Do I have to put it in front? I'm pretty sure I don't. I'm pretty sure this is not correct. Okay, I don't think that's beating our time exceeded took too long. Something is wrong here with this. Find next balloon. I'm a little bit curious. I mean, I've solved the problem. But I'm curious why this find next balloon is not doing the thing I want it to. So I feel like I feel a little bit obligated to find out. I think there's a bug in the find next balloon that is causing it to return the wrong thing. That's causing it to go into some kind of infinite loop. That's my guess. Okay, visualize execution. Can I sort of come over here? Okay. Next. Okay, cool. So this one next does. I had no idea. So he jumped all the way to here. So take away this one. This is one more than two. So balloon. Balloon 0. Okay. Pop it. Oh, actually go here. Okay, next. Okay, now balloon is 2. Yeah, that's correct. Let's keep going. Yeah, no, that's correct. What's the problem? Okay, so a time limit exceeded on this guy. Oh my god, this guy is Nephros. Okay, I see what's happening here. Okay, so we're not finding this in the most optimal way possible. Alright? I'm actually a little bit surprised that my custom solution is actually slower than this Pythonic one. I'm a little bit disappointed, to be honest. What's happening here? I think what's happening here. No, I don't think that's the reason. Let me see if I can do this. Let me copy a bunch of these. I know this is not going to be correct. Let me copy a bunch of these. I wonder if Python Tutor will let us do this. But you know, there's only one way to find out. Programming, just like in life, if you're not sure, try it out. Right? Shoot your shot. They don't let me do it. What about this one? Alright. Come on, guy. Alright, beautiful. This is taking a while. Okay. More than 2 megabytes of data. And it's tracing, so this program is taking a long time. I wonder if I can just... I wonder if it has something to do with negative numbers. Let's just have 3 balloons. You know what? Let's have a few more balloons in there. Let's have about... This is like 8 or 10. Okay, cool. Now we're in business. So let's run it. Okay, we're gonna go to here. Okay. So we have 1, 2, 3, 4, 5, 6 balloons. Okay. So the first balloon is at negative 8646. So this is a pretty large number. Okay. The smallest Yeah, let's see which one it goes to. Okay, let's go to here. So balloon is 2. So it says the guy, the first unpopped guy is 0, 1, 2, which is here, minus 4, 3, 7, 8, 7. This is a fairly small number. Okay, this is smallest number. Yep, that's correct. Alright, so it says balloon narrows 5 plus 1. And based on this guy, we are going to pop. We're gonna pop balloon 1, balloon 0, balloon 2. Does it pop balloon 3? It does not pop balloon 3. Okay, let's see what balloons pop. So it popped IDX3, yep. So popped equals to 2, so it popped balloon. Okay, so the logic is correct. The logic looks correct. I think maybe this code is a little bit slow. I wonder how we can make this code faster. I'm still a little bit miffed that the Pythonic version actually got things done a little bit quicker than me. But I am a human. I can make this even faster. So the way to make this even faster is that we're not going to search. We are not going to search. We are not going to search. Okay, so here's my plan. We're not going to search for the next smallest balloon every single time. This is clearly not a good way of doing it. Instead, the way we're going to do it is we are going to take ends. Okay, so ends is, so starts is sorted, right? Because we sort all the balloons. This points are sorted, guaranteed the starts is sorted. So ends is not sorted. Ends is a little bit jagged. You can see here. Ends is minus 8642, and then it's minus 11, and then it goes to number 3, which is minus 40,000. It goes smaller, and then it comes to this guy, which is a positive number, 22,000, which is fairly crazy. Yeah, so it sort of jumps around. Right? So the problem with this is that it jumps around. That's not a happy thing for us. That's not great. So because it jumps around, so if we're iterating over the list many times, it's because it jumps around. We want to make it such that we want to sort the list only once. And the way we're going to do this is actually we are going to take ends, and we're going to sort it, and we'll produce not just a sorted version of ends, but but the index of the corresponding values that is sorted. Does that make sense? So for instance, this is input is 3, 2, 1, 4, 5. Okay, which you sort 3, 2, 1, 4, 5, you get 1, 2, 3, 4, 5. The index of 1, 2, 3, 4, 5 is index of 1 is 2, index of 2 is 0, index of 3 is 1 here, index of 4 is 3 here, index of 5 here is 4. Okay. NumPy. Oh my god. Axons. Yeah, so we could have numpy, which I don't know if we can do that, or we can do this, which is a pretty clever way of doing it, I have to admit. Okay, so let's do this. So we're going to sort ends, and the way we're going to do it is we are going to enumerate ends. Enumerate actually doesn't it returns an iterator. Yeah, I don't think the enumerate will do the thing we wanted to. So instead, what we're gonna do is there should be. Yeah, I guess this is one way of doing it. Yeah, well, let's at least try to be a little bit Pythonic about it. And what we don't even add. Equals. It's not exactly enumerated. This work. I think it'll work. Okay, so this is what's happening. I don't know whether this works. Okay. Just run it and see what it does. Does it work? Invalid syntax. Oh boy. For blah in blah if. Okay, I got a syntax wrong. For expel in enumerator ends. This should work, I think. Yeah, okay. So I'm gonna sort this down. And what this does, first I'm gonna get a list of pairs. Okay. Instead of index value pairs, I'm gonna get value index pairs. I'm gonna get an enumerated ends dot sort. Okay, I'm gonna sort them. What this does is basically sorts by the value. And then I'm going to get text equals to another one. Sorted index. Oh no, I didn't mean to submit. Now it's going to take a long time. Okay, so what I'm doing is, first I'm going to create a list of pairs. It's based on enumerating ends. I want to get an index, right? Let's come back to this. I want to get an index, right? I want to get index of the sorted version of this. So this is input, this is ends. The sorted version is this. I want to get the index here. So first, I'm going to turn this into a list of pairs of these values and their indices. So it could be 2, 0, 3, 1, 1, 2, 4, 3, 5, 4. And then I'm going to sort them. If I sort, because the way sorting works, it's going to sort the first. It's going to sort the first value. It's going to sort the first value. And what happens when they sort the first value? Yeah, and index. Okay, so now once I have this, I no longer need this thing. Okay, I don't need this thing anymore. I basically iterate over this guy over here, this sucker over here. This sucker over here. Okay? And this will be the index of everybody sorted if balloon smaller than part. Continue. That's it. No, not correct. Oh, smaller equal to pop. Continue. Oh, correct. Let's run it. Let's see if this is faster. It should be faster. Oh, 7 seconds. It's a little bit faster. Holy smokes. I'm pretty sure there are even faster ways to do this. So I don't need this find next balloon, because find next balloon is slow. Okay. I'm pretty sure there are even faster ways of doing this. I just don't know what they are right now. And more importantly, I'm not gonna bother trying. I think this is as fast as I can make it. I think the memory consumption should be, it's exactly the same, but it should be consistently faster than what we were doing before. So this will only sort everything once. It will sort everything once. And you'll get the index. And this should work. Okay, either way, I think we've come to the end of our stream for today. We've done good work for today. So thank you everybody for tuning in, and hope to see you